So today we're going to be working through the topic 1 test review. So you can use this review to help you get ready for the test. So let's do it. Okay, question 1 is asking you about those key features of functions. And so reminders, if you check out your overview, key features, we have all these pictures here. Number 1, ask you for 1A, ask you for positive part of the graph. Those are the parts of the graph that are above the x-axis. And the negative parts will be below the x-axis, and you want to give the x values from left to right. So if I apply that here, the parts of the graph that are above the x-axis are here and there. And I'm going to give x values, so everything before x equals -4, and also everything after x equals 2. And I'm not including, because at these points the graph is not above the x-axis, those y values are 0. Those y values are not positive. If you put it in an interval notation, the interval notation would look like -∞ to -4. Do not include 4 because the y value at 4 is 0. It is not positive. And then also from 2 to infinity. The negative y values of the graph go from here to there, from here until that x equals 2. So everything between x equals -4 and x equals 2 has a negative y value. So as an inequality, you could say -4 less than x less than 2. In interval notation, you could say everything from -4 to 2. For increasing and decreasing, if you look at your overview, the increasing and decreasing parts of the graph are the parts that either go up from left to right or come down from left to right. And again, you're going to give the x values there. So for my graph, let's start with the decreasing part, because if I jump on the left side of the graph, it starts decreasing until we get to this x value of -1. So the graph decreases before -1. I could say x is less than -1, or in interval notation, -∞ to -1. Oh, I put that on the wrong line. Sorry. X less than -1 is the decreasing part, or -∞ to -1. The increasing part is the other half of after the parabola, or after the vertex of that parabola. So from x equals -1 and forever and ever and ever towards infinity. So then we would say all the x values that are greater than -1 have y values that are increasing, or -1 to infinity. For number 2, average rate of change. For average rate of change, let's see, I think we wrote that down. Yes, the average rate of change is the slope from one point to the next. And there is the slope formula, but we'll write it down again. But when it says the average rate of change over the interval from 3 to 8, these are x values. So this would be like x1, and 8 would be x2. So x1, y1, and x2, y2. So the average rate of change formula is y2 minus y1 over x2 minus x1. So if I substitute those values in, I would have 5 minus 2 over 8 minus 3. 5 minus 2 is 3. 8 minus 3 is 5. So the average rate of change is 3/5. Number 3, ask you about some transformations of functions. And on our overview, we listed those transformation of functions and how you can identify them. A lot of them dealt with adding and subtracting numbers inside and outside of parentheses. So if you add or subtract inside or outside, that would be a horizontal shift. Whereas if you add or subtract a number outside, that's a vertical shift. And I also happen to have those copied and pasted here for our convenience. So we have to look at these equations and describe the transformations that are applied. So the way that you look for the order, you want to look for order of operations. So you're going to find the x and then see what happens to the x. You also need to identify what the parent function is. So I see these absolute value bars on part A. That tells me that the parent function is y equals the absolute value of x. And so everything that's different would be associated with a transformation. So when I see this minus 2 inside of the grouping symbol, that makes me think, oh, okay, there's a minus inside of a grouping symbol, so this parent function is going to be shifted to the right 2. And then, let's see, the next thing that would happen in the order of operations would be to multiply by 2. So if you multiply outside of the grouping symbol, that would be a vertical stretch. So we're going to have a vertical stretch by a factor of 2. Then there's a negative in front of the grouping symbol, so that corresponds here, which would be a reflection across the x-axis. And then finally, the last thing that comes with order of operations would be this plus 3 at the end, which goes with this, which is this is shift up 3. For part B, I notice I don't have absolute value bars anymore. Now I have x squared, so that tells me my parent function is y equals x squared. And then I notice that first of all there is a plus 1 inside of a grouping symbol, so I'll erase these so I can find them. Plus 1 inside of a grouping symbol corresponds right here. So that tells me first the parent function would be shifted to the left 1 unit. It would then, let's see, the next thing that would happen is this 1/2, which would be a vertical compression by 1/2. And then this minus 2 on the outside is down. So we're going to shift down 2. And then finally, for the last one, I have another squared happening. So that tells me the parent function is y equals x squared. Then I look inside the parentheses, I see a minus 1. So minus 1 inside parentheses would be a shift to the right 1 unit. And then the only other thing that happens is this minus 1 outside, which would be minus 1 outside is right here. So that would be a shift down 1 unit. For number 4, it says write the following absolute value equations in the form y equals a times the absolute value of x minus h plus k. So what we're trying to say is that each of these needs a value for a horizontal shift, a vertical shift, and a stretch, and maybe even a reflection. So I need to go through and pick those out. It's a good idea to remember that the parent function for y equals the absolute value of x looks like a V with the origin, let me graph it in green actually, as the point of its vertex. And it's not shifted at all. It's got a point at 0, 0, 1, 1, 2, 2, 3, 3. Then it is symmetrical. So here is the parent function. Okay, so then my job is going to be to make this green graph shift to be on top of the black one. So that means I compare them and I notice, okay, well this vertex to get to be down here, it needs to shift left 1, 2, 3 units. So to shift it to the left 3, then I need inside the grouping symbol to add 3 units to make it go left 3. And again, you can double check on your overview. Left, you're adding inside that grouping symbol. So if I shift that whole graph left 3, Now it looks like this. And if I get rid of the green one, whoopsie. If I get rid of the green one, shift to left 3. Okay. Now to make the orange graph match the black one, I need to make it shift down to that vertex, and that's 1, 2, 3, 4, 5 down. So I need to go down 5. So then to make that equation shift down 5, y equals absolute value of x plus 3, but then minus 5 on the outside of the grouping symbol. If I shift that whole graph down 5 units, oh look, now they match. And I'm done. For the second one, I'm going to follow the same thing. I'm going to start by graphing the parent function, y equals the absolute value of x, and then see what types of transformations will land me on top of that black graph. So here's the parent. Okay, I look and see that it needs to shift to the right 2 units. So shifting right 2 would be y equals the absolute value of x. To go right 2, I need to subtract 2 inside of the grouping symbol. So if I take that graph and move it to the right 2, now it looks like this. And I say, hey, I notice that graph needs to be reflected across the x-axis. So I'm going to reflect it across the x-axis. And to do that, you need to put a negative in front of the absolute value bars. So that takes this graph and now moves it like this. I'll get rid of the other one. And then I say, okay, that vertex needs to go up a little bit. Looks like it needs to go up 1 unit. To do that, you're going to need, oh, I had a parentheses. That should be a bracket. To go up, I need to add 1 on the outside of the grouping symbol. So I'll put a 1 there. But my stretch doesn't look quite right, does it? Because the vertex is in the right spot, but the stretch is not what it needs to be. So I need to find that rate of change. So if I look at this a little bit closer and say, the rate of change from this point to this point is up 1, 2, and right 1. So it goes up 2, right 1. That tells me that my average rate of change is 2, and so that is my A value, is 2. So my final equation, y equals negative 2, absolute value of x, minus 2, plus 1. And then, if you want to double check, you can graph it on Desmos. So if you take a look, oh look, they are the same graphs. And you can say 2, 1, and let's see, there's a point at negative 3, 0. Oh look, negative 3, 0. And you will be able to use Desmos while you take your test, but you do have to show all of your work. Right, now let's look at question 5. Question 5 is going to ask you to graph the piecewise function and state the domain and range and fill in the missing values. Okay, so when I go to graph this, I notice that this piecewise function has 2 pieces. The first piece is a 2, and so that's a constant function, so the first piece will look like a horizontal line. The second piece will also look like a horizontal line. So then I'm going to go and fill out my table of values. So if the input is 8, then I notice that 8 is greater than or equal to 5. So if the input is 8, then I'm going to use this formula, which is just the 2. So if the input's 8, the output is 2. So there's a point at 8, 2. If the input is 5, I will also use the same formula because this formula applies if x is greater than or equal to 5. So the output is still going to be 2. If the input is 0, then I'm going to start to use the second formula because 0 is less than 5. So my output will be -3. So there will be a point at 0, -3. And if the input is -2, the output is would also be -3 because -2 falls in the same category. Okay, so there's also a point at -2, -3. Then I need to plot my other point, 5, 2. Oh, I plotted 8, 2 wrong. 8, 2 is here. Okay, and then I can fill out some more dots. So if my input is 5 or greater, the output is going to be 2. So 6, 2, 7, 2, 8, 2, 9, 2, 10, 2. Anytime the input is greater than 5, that means any of these x values greater than 5, output's always going to be 2, and I need a closed circle at 5. The output would be -3 if the input is less than 5. So if the input is 2, the output would be -3. If the input is 3, output's -3, all the way until we get to 5, but we do not include 5, so everything that way. So the graph is done. The domain, the graph touches all the x values. It touches all the x values that are less than 5. It includes the values that are 5 and greater than 5, and then everything after 5. So my domain would be all real numbers, or -infinity to infinity. The range are just the output values. Well, this graph only has 2 outputs. It has 2 and -3. So -3 and 2 are my only outputs. And because it only touches 2 outputs, I need to use these braces. Okay, let's see, number 6 says to select the correct graph for the piecewise function. So I notice all of these graphs look very similar. They all have -2 as an x-intercept. They all have 3 as a y-intercept. The only thing that seems to be different are the open and closed circles, perhaps. So then I'm going to look for those. On the first part, x plus 2 is for x is less than 2. So that means for that first most left side, I should have an open circle, not including. So it cannot be A, and it cannot be D, because these are the only 2 that have open circles. And then I also notice here it has or equal to first, and then not including. So I'm looking for something that has a closed circle and then an open circle. So let's see. Oh, that has to be B. Has to be B. The next one says Jose takes a job that offers a monthly starting salary of $4,000 and guarantees him a monthly raise of $145 during his first year of training. Write the explicit formula of his arithmetic sequence, and I think it also means to calculate. Calculate his monthly salary at the end of his training. Okay, so first we'll start with the sequence. So we know that it starts off in Jose's first month, he gets $4,000. Then it says he gets a raise of $145 every month because it says monthly. So the next month, his monthly salary would be $4,145. And then the next month, if I add another $145, 4,145 plus 145, I would get 4,290. And this would continue during his first year of training. So they say, the question says, Write the explicit formula. So let's start with that. The explicit formula is this. And this is a formula you need. So it's A sub n equals A1 plus the common difference times n minus 1. So A1 is my first term, which would be 4,000. The common difference is how much is being increased or decreased from one term to the next. So that would be 145. And then we do not substitute anything in for the variable n when we're doing the explicit formula. Then we can simplify this expression, so 4,000 plus 145n minus 145. If I combine like terms, that would be 4,000 minus 145. So my explicit formula would be 3855 plus 145n. So there's the explicit formula. The next thing we're supposed to do is we're supposed to calculate his monthly salary at the end of his training. So come over here. That would mean there are 12 months in a year, so I want to know what is his salary during the 12th month, or what's the 12th term of this sequence. So I'm going to take that formula and substitute in 12. 3855 plus 145 times 12. Then I grab my calculator, I'm going to type that in, and I get $5,595. So in the 12th month, Jose would make $5,595. Number 8 says a large multiplex house has many theaters. The largest theater has 41 rows. There are 18 seats in the first row. Each row has 4 seats more than the previous row. How many total seats are there in the theater? So since it says total seats, that makes me think I need to add some things up. So I'm going to use the sum of the first n terms formula, which is S sub n. And again, this is also on your overview, but you need to have it memorized. It's this formula right here. Equals the first term plus the last term divided by 2 times the number of terms. And we will substitute in everything that we know. So I want to know how many total seats there are in the theater. So I want to know the sum of the first 41 rows. So let's see. The sum of the first 41. Let's try that again. It's going to be my first term. There are 18 seats in the first row. Each seat, I don't know what A sub n is. Okay. And 2, and I know there's 41 rows. Okay, so I'm going to have to come back and plug in this number. So I'm going to come over to the side and find out how many seats there are in the 41st row. So I'll take A sub 41, and I'm going to use the explicit formula, which is A1 plus the common difference times n minus 1. But this time I know which row I'm on. I'm on the 41st row. So that first term was 18. Each row has 4 more seats, so the common difference is 4. And I'm going to substitute in 41 to figure out how many seats are in the 41st row. So that's 18 plus 4 times 40. I grab my calculator. I get 178. So I can replace A sub n with 178, and then I will calculate the sum of the first 41 rows. So I'm going to type in 18 plus 178. I will divide that number by 2, and then I will multiply it by 41, and I get 4,018 seats. For number 9, you're going to want to use the Desmos graphing calculator to find the sum. Drag this down. And so you can do that. You can grab Desmos. You can type in SUM from n equals 1 to 16. And just make sure you use parentheses. 4n minus 11. And you get 368. For number 10, we need to solve both equations graphically. To solve both equations graphically, now I know you could solve y equals 2x minus 3 equals 1. I know you can solve that algebraically, but here you're asked to solve them graphically. So that means you're going to graph the left side, y equals 2x minus 3, and you're going to graph the right side, y equals negative 1. I wrote a 2. Now as a reminder, we did this in section 1.5. Where is it here? Where you had an equation, you graphed both sides. You want to see where the two intersect, and you're going to give the x value as the solution because the equation only has x's in it. So back to this one. I'm going to graph the left side y equals 2x minus 3. So if I graph it by hand, then I know that my y-intercept is negative 3, which is where I will put my first point. And my slope is 2, or 2 over 1. So from that point I will count up 2 and write 1, and up 2 more and write 1, and up 2 more, write 1, up 2, write 1. And then I can also go down 2 and back 1, but then I would be off the graph. If I connect all these dots, I've graphed y equals 2x minus 3. Now I'm going to graph y equals y equals negative 1, which is the constant function where all the y values are negative 1, which is this line right here. So this is y equals negative 1. And I see that the two lines meet right here at the point 1, negative 1. But remember that your solution is only the x value where those 2 points intersect. So my answer to this problem is that x equals 1. For B, if I graph the left side and the right side, I will be graphing y equals the absolute value of x minus 4, which is the parent function y equals absolute value of x, but shifted to the right 4 units. So I'm going to go 1, 2, 3, 4, and I will graph y equals absolute value of x minus 4. You can check this graph by picking out Desmos, typing it in. Then I'll also graph the line y equals 2x plus 1 with a y-intercept of 1 and a slope of 2, so up 2, right 1. Hey look, they intersected. Down 2, back 1. And they intersect at the point 1, 3, but my solution is the x value here because the equation is only in x's. So my answer is that x equals 1. On 11, we're looking to see where that interval is satisfied. Square root or x squared minus 4 is greater than or equal to 0. Greater than or equal to 0 is another way to say positive. Or 0. So we're not just looking for where the graph is above the x-axis, but we're also looking for where the graph is equal to 0. So I look and say, okay, well that's here. This graph looks really familiar. And there. So everything before negative 2, so all the x values that are less than or equal to negative 2, and everything after positive 2. Make sure you include, because we're including the zeros there. If you write it in inequality or in interval notation, it would be negative infinity, comma negative 2 with a bracket, and 2 to infinity. Now we get to solve the systems of equations algebraically. So algebraically means you have to solve it without graphing it or without a matrix. So right here, I could pick to do this either with substitution or elimination. But if you're asked for how to solve it algebraically, you've got to use one of these two, because the other two methods, matrix and graphing, are not solving it algebraically. So I'm looking at these two, and I notice, hey, look, my variables are all stacked. The x's are over the x's, the y's are over the y's, and the constants are over the constants. This is making me think this is a really good problem to solve with elimination. I also notice that these x's are opposites of each other. So if I try the elimination method, I notice that these two already would cancel each other out if I were to add the equations vertically. So that's what I'm going to do. If I draw a line and add those two together, negative 6x plus 6x is 0. 3y plus y is 4y. And negative 9 plus 45 is 36. And then if I divide both sides by 4, y is equal to 9. So I get y equals 9. And I'm not done yet because I still need to find x. Notice that this equation has x and y, so my solution needs to have an x and a y. So I'm going to use either equation. I think I'm going to pick the top one to find the x. So 6 times x plus 3 times whatever y was equals negative 9. Well, we found out that y was 9. So now I'm going to simplify. 6x plus 3 times 9 is 27 equals negative 9. If I subtract 27 on both sides, I get that 6x equals negative 36. So x equals negative 6. So the solution to this system of equations is negative 6, 9. For number 13, we're going to graph the system of inequalities and shade the overlapping region. So I'm going to graph the first one. It is already in that form y equals mx plus b. So I notice the y-intercept is 2, and my slope is 3. Y-intercept is 2. Okay, so if I put a point at 0, 2, the y-intercept, and I count the slope, 1, 2, 3 over 1, 1, 2, 3, back 1. And because it is or equal to, we're going to use a solid line. If it doesn't include or equal to, we'll use a dotted line. So I will connect these with a solid line. And then it's going to be up to me to decide which region I'm going to shade. This inequality says shade the part where the y values are greater. So that would be everything above the line. So I'll shade all that in. Okay, now I'm going to work on 2y minus 8 is less than x. That one, if I'm going to graph that by hand, then I need to rearrange it so that the y is all by itself. So if I add the 8 to both sides, I'll have 2y is less than x plus 8. And then I can divide everything by 2. So y is less than 1/2 x plus 4. Oh, I added or equal to. Y is just less than. So now I'll have a point at 4. And my slope is 1/2, so I'll go up 1, right 2. Up 1, right 2. I can also go down 1 and backwards 2. Down 1, backwards 2. It says make it dotted. So there we have it. And it also says to shade where all the y values are less than. So I'm going to shade this region. And my solution is where those two overlap, which would be this area right here, solution. We're going to write a matrix to represent the following system. So our system is 2x minus 3y equals negative 7, and negative x plus 4y equals 10. So if I'm going to write a matrix, then what I need to do is I need to make sure my equations are stacked. So I want to make sure all the x's are stacked above each other, all the y's are stacked, all the equal signs, and all the constants. That is happening here. Yay! Okay, so then all that we have to do to create the augmented matrix is to copy down all of the coefficients and the constants without any variables or plus or equal signs. So my augmented matrix would be 2, -3, and make sure you do include the symbol in front if it's a negative especially. -7, -1, 4, 10, and then we put this dotted line where you would see the equals going. And this just says write the matrix, so you don't have to do anything else with that. Just leave it how it is. There's our answer. On number 15, it says to solve the system, and since there are 3 variables and 3 equations, I would solve this with a matrix. So first I'm going to set up my well, first I want to make sure all my x's are stacked over each other. Yes. What about the y's? They are over top of each other. Z's all over top of each other's, and constants. Yes, everything is stacked over top of each other. Okay, then I'm going to make my augmented matrix. First row will be 1, 1, 1, dotted line, -2, 5, -1, -8, -51, -1, -1, -7, -28. And if we find the reduced row echelon form of that matrix, we'll be able to see what the solution to the system is. So I'm going to pull up Desmos, and I'm going to type in that matrix. So I'll slide this here. Well, maybe on the right side. And then I'll grab my Desmos calculator, and I'll move it to the left side, and I will type it in. Oh, I don't want my Desmos graphing calculator. You can go to desmos.com/matrix, and it will bring you to the matrix calculator. So my new matrix, I want to have, let's see, I want to have, how many, oh, looks like I'm going to have 3 rows, 4 columns. First row, 1, 1, 1, -2. Next row, 5, -1, -8, -51. Last row, -1, -1, -7, and -28. So I'll enter that matrix, and then I will click RREF of matrix A, and I'll get -3, -4, and 5. And I'm just going to double check to make sure everything matches. 1, 1, -2, 5, -1, -8, -51, -1, -1, -7, -28. Yes. So when we write down our solution matrix, we took the reduced row echelon form, and we got this matrix: 1, 0, 0, -3, 0, 1, 0, -4, 0, 0, 1, 5. So that would mean that 1x plus 0y plus 0z equals -3, which means that x equals -3. From the middle row, this is where the y is, we could see that y would be -4. And then from the last row, that's where our z would be, we see that z equals 5. So my solution here is -3, -4, 5. For part B, again, I want to make sure, oh no, our equations are not stacked. So I'm going to have to make that happen. So for the first line, that's going to be changed into 2x plus 2y plus 0z equals 50. And then x plus y minus z equals 0. For the last equation, there are no x's. this negative 2y needs to be on the left side, plus z equals negative 5. Now if I type that into my matrix calculator, pull it to the side. Well, that didn't quite go where I needed it to. So I'll do a new matrix. I need, hold up, I need 3 rows and 4 columns. And my matrix will be 2, 2, 0, 50, and 1, 1, negative 1, 0, 0, negative 2, 1, negative 5. Okay, then I'll take the reduced row echelon form of matrix B, and I see my answers are 10, 15, and 25. So x will be 10, y equals 15, z equals 25. Number 16 has a typo, so please make sure that you fix that. And then, so you don't, originally I think your paper says to have 4 times as many $110 tickets. It should really say he wants to have twice as many $50 tickets. So here's what we have to do. To solve this, the first thing you want to do is you want to define your variables. So it's the last sentence that tells us what we're trying to find. Find how many seats he should have in each section. So we're going to let x be the number of seats in the $50 section. Y will be the number of seats in the $80 section. And then z will be the number of seats in the $110 section. So we are going to write, we have 3 variables. That means we need 3 equations. First of all, we know that there are 3,300 seats total. So if I take the number of seats in the $50 section plus the number of seats in the $80 section plus the number of seats in the $110 section, we get 3,300 seats. The second thing I know is that altogether we want to earn this much money. So for the $50 section, if you take the number of seats times $50 plus $80 times the number of seats in that section plus $110, that's 100, times the number of seats in the $110 section, we want to have $210,000 total. 2 equations, great. Next, we want to have twice as many $50 seats as the sum of the other tickets. So the other tickets, so the $50 seats are the x, right? So we want the number of x seats to be twice as many as the sum of the other 2, y plus z. And if you distribute that, x is equal to 2y plus 2z. But if I want to put it in my matrix, I want to make sure that all my x's are stacked and all my y's and z's. So I'm going to move the variables all to the left side. So I've got the x. I need to subtract the 2y from both sides, subtract the 2z from both sides, and then there's nothing left on the right side. So now I will take this information and I will find my augmented matrix, which is, I believe it's right here. So I have
let's see, new matrix. I need 3 rows, 4 columns, 1, 1, 1, 3, 3, 0, 0, and I need 50, 80, 110, and 210. I think I need another 0 right there. 210,000. There we go. 210, 1, 2, 3. And then finally 1, negative 2, negative 2, and 0. And we'll find the reduced row echelon form. Oh no, I accidentally deleted a row. Hold on. Add a row. Type it in again. 1, negative 2, negative 2, 0. Okay, I will not delete that. I will enter that. And we'll take the reduced row echelon form of matrix E, or matrix D. And that's how many tickets we have. So we're going to have 2,200 for X, 700 for Y, and 400 for Z. So 220 seats in the $50 section, 700 seats in the $80 section, 400 seats in the $110 section. So there we go.